All right, good afternoon, students. Good afternoon and welcome to all of you, representatives from the National Science Foundation, invited speakers from various universities and organizations, the T.C. Williams staff and students to our Women in STEM program. My name is Peter Ballast and I am the principal of T.C. Williams High School, the largest and most diverse high school in the Commonwealth of Virginia. I'd like to send a special thank you to NSF and Alexandria City Public Schools for hosting this event. What a wonderfully relevant and important topic to discuss with our Titans. Did you know that last year, a TC student was recognized as the top teen scientist in the whole country? The field is very important to our staff and our students, and I'm always astonished by our student talents. It's my pleasure now to introduce Dr. Marin Jo, the Assistant Director for the Directorate for Education and Human Resources at the National Science Foundation. Her vision for STEM education and research guides the work of all divisions and programs within the Directorate. As a leader in the research community, she's deeply committed to including everyone in science and engineering, especially young women. Please welcome Dr. Marin Jo.
Good afternoon, everyone. My daughter is a future Titan, so I'm thrilled to be here. I am happy and truly honored to join the group of phenomenal women in STEM who you are going to hear from today. Before I speak, I want to share a video about the National Science Foundation, which was just released last month. Next year, NSF will celebrate its 70th anniversary, and this video explains who we are, what we do, and why our work is so important.
Government has a responsibility to see that our country maintains its position in the advance of science. As a step toward this end, the Congress should complete action on the measure to create a National Science Foundation.
For 70 years, NSF investments in people and places have helped build the backbone of America's scientific enterprise. We focus on the large, big questions, big projects. It means taking risks, staying the course, because game-changing breakthroughs don't come quickly.
We have seen what we thought was unseeable.
We focus on the small, where a single piece of new knowledge can advance an entire field or save a life. We are about exploring the world from the top, the bottom, and everywhere in between. We are about big ideas and bold vision. You see the results everywhere. Innovations, marvels, built on a foundation of research we empower. We make the impossible possible. Who are we? We are pioneers, risk-takers, visionaries, who stand with the bold at the frontier's edge. And together, we transform the future. We are the National Science Foundation, and this is where discoveries and discoverers begin.
As you can tell from the video, NSF is proud to support all kinds of science and engineering research for all ages and across all kinds of environments, including outside of the classroom. What we call citizen science projects engage the public to help collect and analyze data for scientific research. There have been so many amazing discoveries and advances in science that have been made by men, women, and students like yourselves. For example, middle and high school students in New York City are at the center of a movement to restore the oyster population in New York waterways. As part of this project, called the Billion Oyster Project, students learn about marine science, biological oceanography, marine technology, and species and habitat preservation. Students also learn how to conduct science, how to test water quality, collect data about oyster health, and how to design and run an experiment and do research. Why would they want to work with oysters, you may ask? Because oysters play an important part in the New York harbor ecosystem and even protect New York City from storm damage by reducing flooding, preventing erosion, and softening the blow of large waves. Students just like you are directly helping to keep the city safe and the New York City harbor thriving. NSF has also worked together with other federal agencies to create learning opportunities for the public. One such example is the GEN Cyber Camp program, supported by NSF and the National Security Agency. The GEN Cyber program provides summer cybersecurity camp experiences for students and teachers in elementary, middle, and high schools. This summer, 122 cybersecurity camps operated across the country, all at no cost to participants. The New Yorker released a story on the camps this past August and reported that there were camps for girls in South Dakota, Maryland, Puerto Rico, and South Carolina. A camp in Pennsylvania that simulated an airport hack, and one in Georgia that disarmed a car hacking. So if you want to learn how to hack ethically and not get in trouble, tell your parents that you want to go to a GEN Cyber Camp. I want to end my brief remarks today by reminding you that each one of you here is a scientist. Since you were very little, you've been learning about the things around you and asking questions about the world. You are the next generation of discoverers. And I hope that you always find the courage to ask questions, make mistakes, pursue opportunities, and seek out peers and mentors that can help guide and support you on your path towards knowledge. So as you tune in to the rest of today's event, I invite and challenge you to dream what could be, just as every scientist, engineer, and mathematician before you did. Don't let the existing ways limit your possibilities. Thank you. And now I am pleased to introduce my colleague, Chris Brown, who's the Deputy Associate Administrator in the Office of STEM Engagement at NASA.
Thank you, Karen. Hi, everyone. It's great to be with you all today. And I'm thrilled to have a chance to share with you how you can learn more about NASA and engage with us and the amazing work that we do. At NASA, we're really proud of our super talented and the dedicated people who are doing exciting work every day and making NASA's missions successful, especially the contributions from our extraordinary women in STEM. We need more people in STEM at NASA, and we're looking also to grow our cadre of women as well. And we have a tremendous cadre already at NASA, and we just celebrated our first all-female spacewalk back in October with astronauts Jessica Meir and Christina Koch. That was the first time we had two women doing an EVA. We were really excited about it. My organization is committed to developing students, all of you, young women and men, and launch you on your careers as the next generation of explorers. Looking at our exciting challenges that lie ahead, at NASA we need a wide range of people from diverse backgrounds to enable us to make tomorrow's discoveries and to push further into space than ever before. I'd like to share a video with you that will give you a glimpse of our fabulous people and an idea of what it's like to work at NASA.
Ignition sequence start. All engines are running.
We have taken tremendous steps.
We choose to go to the moon before this decade is out.
We have achieved the earth-shaking, the breathtaking, the groundbreaking,
One small step for man,
and left a mark in the heavens. Our successes build one upon another and amplify what is possible.
The dawn of Orion.
It's time we take the next great leap. We're building the next chapter of American exploration, returning to the moon to stay, so we can go beyond to Mars, to expand what's possible and further our understanding. The architecture for these missions is already taking shape. We will go with new systems, bold designs, and a sustainable mission. You can hear it, taste it, touch it. We are going. We are training, testing, pressing our pioneering spirit into every component, defining our resolve with every line of code, and securing our success with every welcomed partnership. This is not hypothetical. This is not about flags and footprints. This is about sustainable science and feeding forward the advance of the human spirit. Because we are the pioneers, the star sailors, the thinkers, the visionaries, the doers. And because we stand on the shoulders of giants to go farther than humanity has ever been, we will add our names to the rolls of the greatest adventurers in history. Every day, every mission, we advance this calling. We are NASA. And after 60 years, we're just getting started.
So we are going to plan to launch the first woman and the next man to land on the moon in less than 4 years. Artemis puts us on a path to the moon and then on to Mars. And we want you to join us on our journey. I'd like to encourage you to imagine and dream about what you can do. You could be on a crew to Mars, an engineer or a physicist making discoveries about our solar system and the universe, or a scientist tackling the challenges around our home planet and climate change. Or if space isn't your thing, there are so many tremendously exciting careers in high-tech and STEM fields that you can pursue. I'd like to encourage you, all of you, to consider trying on a STEM hat in 2020. As students, you can engage directly with NASA through a number of STEM opportunities, including our student challenges and competitions. Through these challenges, you can do robotics, launch rockets, build instruments, or build and develop tools that will fly in space. You could also apply for a NASA internship if you're 16 or older, where you can work side by side with NASA engineers and scientists. Many of our employees started off as students who participated in these challenges or internships. I recently met a couple of them, and you're going to be introduced to Lindsay in a little while. Paramita Mitra served as an intern at Johnson Space Center in Texas and participated in our Suits Challenge, where students work to create and design spacesuit prototypes. She's now an engineer working at NASA on the next generation spacesuit. Kelsey Young is a planetary scientist. She started as an intern at Goddard Space Flight Center, which isn't not too far from here. The cool thing about being a field geologist is that her outside world is her office. And she explores craters on Earth to see what environments will be like for astronauts before they land there. I've spent most of my career at NASA as an engineer, that provided me many unique opportunities to be a part of NASA's explorations in deep space and also to learn more about our home planet. I feel really fortunate now to be a part of the NASA leadership team, enabling students like you to pursue unique opportunities in STEM and help launch your futures. I'd like to close by saying thank you for having me here today. You have a terrific opportunity to learn from some powerful women in STEM. I hope you all consider a STEM career, dream and imagine. The universe is out there waiting for you. Thank you.
Thank you, Chris. The next session today is going to be moderated by Dr. Shaena Montanari, who is a science journalist and paleontologist at Arizona State University. We are so glad you could join us all the way from Arizona today.
Hi, everybody. Hi. You don't know how lucky you are today to hear from this amazing panel of women. I'm Shayna, so I'll be moderating the conversation. And I'll get right into it so you can have a chance to hear from them and ask them some questions. So next to me right here is Dr. Anna Carnival. She was born and raised in Brazil. She earned her doctorate at the University of Chicago, and now she's an associate professor of molecular ecology, which you can explain what that is to you, at City College in New York City. She studies the biodiversity and evolution of pretty much everything that lives in tropical areas all over the world, so she can tell you all about it. Next to Anna is Dr. Brittany Brand. She's a volcanologist, which is probably one of the coolest job titles that I've ever heard of, at Boise State University in Idaho. She's a professor there, and she studies how different volcanoes erupt. They all erupt in different ways, some more explosive than others, and she looks into why that is. And she also is interested in helping people understand volcanoes who live near them so they can be safe. And last but not least, we have Lindsay Aitchison. She's an engineer who works for NASA. Okay, maybe her job might be one of the coolest I've ever heard on spacesuit design. So she designs them and has tested them in what's affectionately known as the Vomit Comet, NASA's low-gravity aircraft. So yeah, you have this amazing panel, and I'll get right into it. I think one question, I'll start with Anna, is, you know, growing up in Brazil, was there something that inspired you to get into science? Have you always been interested in this career path? Like, what was your spark?
Yeah, can you hear me well? So in Brazil, actually, it was. I decided to be a biologist, so I went into a major in biology, so we can do that straight out of our school. But
Wait, hold on.
can you hear me well?
I don't think the audio is up.
No, it's on.
Some technical difficulties. While we fix this, I can ask Brittany a similar question, because I want to know why all of you got into your field. Like, what inspired you to be a volcanologist?
That's a good question. Can you guys hear me?
Is any of the audio working? Is that mine?
What about me now?
Okay. It's all good.
Check, check, check. Hello, everybody.
Okay, we're in business.
Right, so what inspired me to be a volcanologist? Well, when I was about 7 years old, my grandmother gave me a rock, my first rock, and it has what I now know is a clear mineral called quartz, but when I was 7, I was convinced it was a diamond and that I was rich. So, check, check, okay.
I think
so my parents didn't believe me, so I had to go to the library, find every book I could. I started running experiments, and at one point, my mom caught me trying to cut the glass in my window because diamond cuts glass, and I assured her it was fine because we could replace it with all the money we were going to get from the diamond. Anyway, so I was inspired at a really young age. I really loved geology and learning about the Earth, and then went to visit my aunt in Seattle, saw Mount Rainier for the first time when I was 12, and it's been volcanoes ever since.
That's amazing. Anna, are we back in business here? Or can you give you
I
that
think
mic?
I need this. Yeah, so I was in school. I was doing my major, and we had one field trip once to this beautiful site. It's a forest site, but next to the ocean in São Paulo. So this is southern Brazil. And there was one night that we went out to look for frogs. And I swear to you, I saw this tree, and it was just packed with tree frogs. There were frogs everywhere. They were jumping in my head and going, you know, everywhere there were frogs. And I just thought, man, this is so amazing to be able to just study these creatures and understand how life evolved and how we can help preserve this planet and this diversity. So that was my aha moment. But I had already been inspired to be a scientist because I came to DC as an exchange student. So it was really the National History Museum that sort of drove me to this field. So it's really your everyday experience that takes you there, really.
I guess, Lindsay, what about you? I guess, what was your spark?
So when I was about 4 years old, my parents, they were taking us on a trip to Disney World, my sister and me. But on the way there, we stopped by the Space Center to kill some time while my dad was doing some business trip stuff. So my mom took us, and we saw an IMAX. And I remember watching and seeing astronauts floating around chasing M&Ms, and I was like, oh my God, that's the coolest job ever. So ever since then, I decided I wanted to work for NASA. And turns out it's not just chasing M&Ms, there's a lot more to it. And so when I was in high school, I went to science camps, I went to engineering camps, and figured out that engineering was really something that excited me. It was a lot of different problems, trying to make something really small into something really really big or vice versa. I thought it was an interesting challenge. And then I was an intern at NASA when I was in college. And it turns out there are a lot of different engineering jobs. And so it was really helpful to have that internship experience to try different areas of being an engineer. So I tried working in flight control and mission control, and that but then I also tried programming, because you want to branch out and make sure this is your job forever. You want to really like. Programming was not it for me. After that, I wanted to try something hands-on. So I tried spacesuits, and it was in the lab every day. It was doing research, it was doing testing, and I really fell in love with that aspect of what you can do between humans and spaceflight. And so I've been doing spacesuits ever since.
Wow. I was going to say, that, like, how do you get into spacesuits? But you explained it nicely. And I think that's a good example of how what you start off with something like you can explore in the field and like kind of learn more about what you want to do. And you touched on this a little bit, so maybe you can start. But if any of you in the audience are thinking, wow, these jobs sound really fun, how can I do that? And you're in high school now, so the world is your oyster. You can do whatever you want. So how do you, what are the kind of school requirements for your career? I guess, Lindsay, you can start, because engineering is a little different than what these two women would.
Engineering is definitely different from science in that really to get started in an engineering career, all you need is an undergraduate degree. And what's great is because there are so many different types of engineering, so many different disciplines, there are a lot of different schools that you can choose from, and they're all going to set you up in a really great way. So as an engineer, just having that undergraduate degree is going to get you started. And then sure, once you get a job, if you really like that job, if you want to get further within your career, you can always go back and get your master's degree. And a lot of times the companies for which you work will pay for that for you. So it's a really great deal.
Brittany.
There's a lot you can do with an undergraduate in geology, but if you really want to go into volcano science and travel the world studying eruption dynamics, then you do need to go on to graduate school, and so that can look like another 2 to 6 years where you're basically getting paid to study volcanoes. So it's pretty awesome, but it does require a graduate degree, so best advice is just whatever you major in, and as an undergrad, do your best you can, because you never know if you'll end up pursuing a graduate degree or not. And so many of you probably will. So work hard in your undergrad, because you never know where it'll take you.
Yeah, and what Brittany said, that they'll pay you, it's true. To go some graduate programs, they pay you a stipend because you're doing research for whoever you work for, so you're effectively working and learning at the same time. So it's actually a pretty good deal. Anna, your experience is, I'm sure similar, because you went and got a PhD, like Brittany was describing, but you said you did an exchange program, and so you have more chance to maybe do international education.
Yeah, I did. I actually did 2 graduate degrees. I did a master's degree first, which was a 2-3-year program, and then I jumped into my PhD, and the master's degree was in Brazil. And for the PhD, I decided to come abroad, and I came, and I never went back. But then I did yet another piece of studying and preparation that some people would do, especially people doing a lot of research at universities, which is a postdoctoral fellowship. So that's yet a 4th level of education that you can have after your PhD. And at a point, a postdoctoral position is really a job. You're being paid to do research exclusively, and it's it's actually, I would say, that is most relaxing, amazing time that you have as a scientist, because you don't have a particular, you're very free to do the research that you want to do, and you don't have your classes to take, and you're just diving into becoming a scientist. So that's the last bit that we can add there.
Yeah, and what's great about grad school is that you do take classes, but you do get to spend a lot of time exploring research and what your interests are. So if you're like, oh, I'm tired of being in class, you actually do get a lot of time to do, focus on what you like, which is one of the best parts about being an academic. So you all have jobs that sounds like you travel a lot, if to upwards in the atmosphere for some of you is the traveling, but also to other countries. So I guess kind of go down the line. I'll start with Anna again. Where in the world has your job taken you? A lot of us love to travel, and this is a great way to do it and see parts of the world you never see. So like, do you get to do it a lot? Where do you get to go?
Yeah, as scientists, we go everywhere. We go to the sites where we study, if we do international work or domestic, but we have, every year, we have 2-3 different international meetings to go to. So it's actually a hard decision to make it. What scientific meeting am I going to go this year? So we travel a lot, And you know, oftentimes our jobs are going to pay for that, or the National Science Foundation or NASA, thank you for our support, so that we can go and present your work and discuss your work with other people and improve and think bigger. So those trips are really important from a professional standpoint, but they're also amazing from a personal standpoint. You're meeting the world out there, you're making connections to people all over the world.
Brittany, I mean, what kind of volcanoes do you get to go to?
Well, I mean, a good question is like, why is there even a field of volcano science? Well, there are 1,500 volcanoes around the world with the potential to erupt, and about 50 to 60 of them erupt every single year. Because of that, because of population growth, there are an estimated 800 million people living at risk from volcanic hazards. So that means as a volcanologist, I get to travel the world. I've studied volcanoes here in the US, I've studied volcanoes in Italy and in New Zealand, and really every volcano has its own character. But by understanding how one behaves, it can give you a lot of ideas how others can behave. So it's definitely a career that will let you travel quite a bit, and some pretty amazing places.
Do you get to go like up close to a
Oh,
volcano?
oh yeah. So absolutely, I've been in the craters, I've seen 7 eruptions, I've poked lava with a stick. So yeah, absolutely, you are, most of the work I do is in volcanic hazards, so we want to know how a volcano is going to erupt in the future. So most of the work I do, I go to volcanoes before they erupt and try to figure out what they've done in the past, because what they've done in the past is the best predictor for what they're going to do in the future. So I go out and I map and I hike and I camp, and if you like that kind of thing, it's definitely a career to consider.
Yeah, if you like the outdoors, it sounds like a great career, but is it dangerous? I mean, because you're so close to an active volcano, like how do you make sure you don't fall in?
Yeah, it's good not to fall in.
Yeah.
It is, you know, the risk tolerance of a volcanologist is a little bit beyond probably what's normal, but it can be dangerous, and you do have to be very careful and very, very respectful of nature. So being prepared, knowing what the volcano is capable of, are there any signs of unrest? A lot of times when I go to volcanoes, they're pretty quiet at that moment. But I have gone to volcanoes where they erupted, like the volcano in Chile in 2015. I was there to teach a class and arrived about a week before the students did, and the volcano erupted the second night I was there. So I had checked the hazard maps. I knew the place where I was staying was outside of the high-risk zone, so I get a first-hand view of this beautiful fire fountain and this eruption. And I would say equally interesting to the eruption was watching how people responded to it, because the older people in the community who had been there for the previous eruptions were pulling out lawn chairs and going, está bien, I know now, it's completely normal. And you know, the younger generation who hadn't experienced these eruptions were panicking and running through the streets and trying to evacuate. And so it was really interesting. It actually motivated a lot of my work in working with communities and science communication and how we prepare these people living at risk, because we all live at risk to something, some kind of natural hazard. And how do we communicate these hazards in a way that people understand them and respond well, prepare ahead of time, and respond appropriately when something does happen. So you just have to be careful. Be careful.
Lindsay, what about you? Where do you get to travel?
I've traveled a lot domestically for my job, and that's because when you're designing a new spacesuit, there are really 2 questions you ask. Where are you going, and what are you doing? Those are really going to fashion the type of protection that your spacesuit needs to have, and also to have the mobility to do that job. So for us, we're not going to be able to send all of our engineering and science teams to those destinations before we send our hardware. So we have to find analogs of those locations here on Earth. And so for us, that means taking our spacesuit hardware out to the deserts of Arizona, to Black Point lava flow. We've been down to Hawaii. And the whole idea is to get as close to a lunar environment as possible so we can really make sure that we understand the tasks that you're going to have to do, whether it's looking for rocks or setting up science experiments, and something that's kind of similar to that location. When we're not in the field, we also have analogs, which again is what we call those simulations of our outer space environment. We have the reduced gravity aircraft that we talked about earlier, and so that's an airplane that It flies big parabolas, and it's kind of like going over the top of the roller coaster and you feel how you come out of the seat right as you go over the top of the hill. It's that same sort of sensation, except you get about, depending if you're flying lunar gravity or zero gravity, between 30 seconds and all the way up to a little over a minute of time in that reduced gravity environment. And so it's a really good way to train not only our astronauts, but to check out our hardware and to make sure it all works the way we expect it in those reduced gravity environments. So we have all sorts of different analogs to really test out our hardware.
So you can explain why it's called the vomit comet. I guess this kind of thing is not
Oh
that
yeah, that's
pleasant.
not really great on the stomach for most people.
No.
Turns out humans weren't wired to do that, and we're not really meant to live in microgravity, so it takes a while for your brain and your stomach to adjust to that whole situation. I personally like to take the motion sickness pills so that I don't have a problem, but some people like to brave it out.
Is it fun?
Oh, it's a blast. It's fun. You can always tell who the first person is if it's their first time going through microgravity, because the first time you start, you're sitting on the floor, and right as you come over the top of that hill, you start to float off the floor, and all of a sudden you're not touching anything. And your first response is to be like in a swimming pool. You start flailing your arms. But the air is not dense enough. If you do this, you just look like you're breakdancing in the middle of the airplane. You're not moving anywhere. And so you really have to learn how to work in microgravity. That means pushing off the walls. It means stabilizing yourself. And so it's really fun to learn how to work in that environment.
I'd like to try it just one time. And take some Dramamine beforehand, I guess. So you all described traveling around the world and all this work that you do, and it sounds like it can be stressful at times. You know, you're always traveling and away from family and friends and moving a lot, probably, to take different jobs as academics. We get, as we mentioned, you know, master's degree, PhD, a postdoc. Those are all, you're moving almost every time. So what are some of your biggest challenges in, you know, a work-life balance and developing that in science? And, you know, what should, I guess, students think going forward about this career, and like things they should, you know, it's nice if you start with the good habits, so then you know, you don't get, you know, kind of overwhelmed, I guess, would be, again, start with Brittany if you want to.
Yeah, sure. So, I mean, I think that even for you guys right now, there are exam weeks, right? There are periods of time that you're particularly busy, that you really just have to buckle down and focus and work really hard. And that is going to follow you throughout your life. If you really want to be successful in life, you're going to have to work really hard, and you're going to have to go above and beyond. You're going to have to think outside the box. You're going to have to challenge common knowledge and go for it. But you have to also be very careful, because when you start working that hard, if you're not also taking care of yourself, making time for the things that you enjoy to do, like sports or singing or whatever it is, then it does kind of push you into this area of being too stressed out. And so my biggest piece of advice is recognizing that, yeah, there are times that you're going to have to just drop everything and work really hard, but that shouldn't be your life, not now and not during your career. It's really important to start trying right now to find that balance where these are the times that I work hard, and this is where I'm going to go have some fun. And taking care of your bodies, eating well, exercising, all of that is really important, because when I think of success, I don't think of the person who has the coolest job or makes the most money. I think about happiness. And to be happy, yeah, you're going to be doing what you love and working hard, but you also have to have your outlets and taking care of yourself. So.
What kind of hobby? Do you have any fun hobbies? I find scientists always, like, they'll say something like, oh yeah, I'm a world champion skydiver or something. I don't know. No pressure.
I don't know. Should I could share. Well, I love to hike and be outdoors and all of that. But a few years ago, I actually also found salsa dancing, which turns out was it turned into a real passion. I love it. I have, in fact, even had a group of 30 students salsa dancing in the crater of Mount St. Helens. It became a requirement of the course. I know it's a little strange, and that kind of sent me into all kinds of different forms of dance with ballet and modern and jazz, and when I turned 30, I found dancing. And so that was unexpected for somebody that didn't own a dress or a pair of heels at the time. So, so that would be, a pretty fun outlet for me.
Yeah, I love that, Lindsay. I don't know if you have anything to add to that, or any fun hobbies that you have in addition to making spacesuits.
I mean, I would just echo what Brittany said. I think it's super important to have a job that you love, because being happy in your job is incredibly important. You're going to spend so much of your life doing that. Make sure it's something you're passionate about and you enjoy doing it every day. So that's really important balance there. As to hobbies, I guess it's a really dichotomy for me. I've always been very sporty, so I have a lot of sports that I've always played. I did cross-country, basketball, track, soccer in high school and all of that. But now I do CrossFit. I'm a CrossFit trainer, and I lift weights. But I'm also really into knitting. Mostly sweaters for my dog, but super fun.
Yeah, I like asking those questions because sometimes I think people see a scientist on TV and it seems like you spend so much time working, which we do, but then somehow everybody always has these like awesome side hobbies and like all these amazing interests. I don't know if Anna wants to.
Well, no, I just want to add that to me, what you were asked about the challenges and how to make it work. To me, what really helped me set up a career and be healthy and happy personally was to have a network around me, people around me. So in my case, it's my family, a group of friends, these, some coworkers. This is my sort of feel safe, keep grounded people. And I feel that we start, making these relationships, establishing them when we're in high school and middle school, and they're so important, right? They have been really important to me. In my case, it's been really hard when I was doing my PhD and especially my postdoc. I had both kids as a postdoctoral student, and I needed to go to field, and I needed to be in the forest looking for frogs and snakes and turtles in the rivers, and I had just given birth. So I had this thing about, do I take the kids with me? Some of them were in Australia, some of them were in Brazil, some of them were in Costa Rica, or do I keep them at home with dad? So having, grandpa, grandma, people, anyone to sort of help you, it's essential. So don't forget to really be committed. Try to advocate for yourself, but don't forget the social. Don't forget this group. We go to places as a group, really.
Yeah, I'm impressed. Did you end up taking your kids into the field?
So I decided not to take the kids. When they were that young. But I had people who took them because they were married to scientists, so they had more of a sort of familiar structure that they could implement in the field. I was camping. I had no running water and no electricity, and I thought, no, and they're way safer with Dad, and I had to go by helicopter to some of the sites. You don't want to take a newborn in some of those situations.
You look at it casually. She's like, yeah, just take a helicopter, like no big deal. Just doing some amazing work here that, you're like the coolest people ever. So I guess, you may be hearing this and being like, wow, I really want to do these careers. Now what do I do? So I guess we'll just go down the line for a couple more minutes, and then we'll give you all a chance to ask specific questions that I haven't asked them yet. If you have any great questions, I know you do. What's one piece of advice you'd give someone, or back to yourself, back when you were in high school, just what can you do to get involved in science and figure out what your passion is?
I would say don't be shy. Go ask. Go look for interesting positions. Look for fellowships, right? I think not being shy is a very important thing. If you are on the shy side, find people who could get you into places. It's very important that you self-advocate and look for these opportunities. So internships are really, really important. There's so many, right? Being involved in doing some of these things will let you appreciate that, wow, I really love this. So maybe this is really not for me. Let me find something else. So just have that hands-on experience. I think that was really useful to me.
So I think maybe some of you already know that you want to be a volcanologist, and that's great. You should email me. And maybe some of you, I have no idea what I want to do in my career, and that's completely fine. In fact, most undergraduates, I think 80% of undergraduates change their major. So be flexible. Go into college thinking, maybe you don't know what you want to major in, and that's fine. This is your chance to explore and to figure out where you fit. And I think a lot of universities right now are moving to focusing less on the specific discipline and more in helping you develop transferable skills, because nowadays, people change jobs on average 11 times throughout their career. So what's most important is to teach you critical thinking, how to think, so that when you take a new job, you can learn on the job, how to learn, how to communicate, how to work in teams. Those are the things that we are really focusing on in college, in all of your classes. And so those are the skills that can take you from being a volcanologist to jumping into the social sciences and behavioral psychology and helping people understand hazards and risk and integrating these diverse fields into something that that you're also passionate about. So I'd say, yeah, don't worry about it if you don't know what you want to do. Even 2 years into the university, don't worry about it. Just keep exploring and know that it will work out. You will find your path.
I think I definitely agree with Brittany on this. It's all about being flexible. I think it's great to have a goal and have a focus. So like, say you want to be a spacesuit engineer. Awesome. You know, that is a job path you can definitely pursue in college, but I think you have to be open to saying yes, because when I think about my team of spacesuit engineers, who else is in there? I'm a mechanical engineer. There's another mechanical engineer. There's an electrical engineer. We have 2 students that are fashion design students that are interning on our team, because it's all about how you think about this problem. We need creativity. We need all those disciplines to come together to really make the best product possible. So be open to opportunities, even if it's not exactly what you think you need to be doing, but it sounds kind of fun. Give it a try.
The fashion design, like it sounds surprising, but it's so obvious that you would need that, and you're designing something that someone's going to wear. So I guess if any of you were like, oh, I'm interested in creative fields and science, you can do both. And it's actually a huge strength. I mean, personally, I was a paleontologist, researcher, and who loved writing, and now I'm a science journalist. So, you really need to be able to write and be creative. And even if you stay a scientist, creativity, because you're constantly trying to think of new ideas, being creative is one of the most important things. So don't think that you have to give up anything. If you're like, I like algebra and calculus and fashion design, you can do it all. You can be a spacesuit engineer. I mean, fashion designer, that's amazing. Well, I think it's about time for us to open it up to you all, and you can come. There's a microphone right over here. If you have any questions, which I know you do, because I heard that you had some good questions earlier this week. Is anyone brave enough to want to ask a question? Go up to the microphone. This is an amazing opportunity. These people flew in just to meet you all and want to talk to you. I can read some of the questions oh, do you have one? Are you going to the microphone? Yay! Yay! Are you wearing a NASA sweatshirt?
Yes.
Oh, okay.
Actually, I can't. A family friend gave it to me. Like, she also works at NASA, apparently. I forgot what field in, but. So my question is, when you guys were, say, my age, like 16, 18, somewhere in that range, what were you like generally interested in? How did you kind of were you like the nerd in the class that wanted to do calculus or wanted to do physics and was like looking up stuff online for how to do all of that? Or were you like a kid that maybe just took some of those classes and weren't really like super interested in it until you found something else out in college or something?
I was very cool and popular. Well, as you were talking, Anna, when you said look it up online, Anna said there was no online when she. So but for me there wasn't online when I was your age, and that is how I got into it. And I think you have like the world's information at your fingertips right now, which is amazing. Also, I was a nerd, but a cool nerd. So yeah, I mean, just it doesn't matter what other people think about what you're doing and if it's nerdy or not. Like if you're enjoying it, like that's all that matters. I mean, the passion will carry you through. What other people when you work for NASA, they'll say, "Oh, now I wish I talked to you in calculus more," or something like that. But I don't know how you all feel about that.
I mean, when I was in high school, I played a lot of varsity sports, but I was also like the president of the ecology club and a member of DECA, So it's a lot of different interests, and I think that's totally cool, right? I think it's about expanding and trying a little bit of everything until you feel like you really belong. I also did a lot of different engineering summer camps, which was great, and I did science summer camps. I thought for a while, maybe I want to be an anthropologist. I don't know, let's go try it out. So it's about, again, just trying everything until you find what works for you.
For me, that's a great question. Thank you. When I was in high school, I rode a skateboard and played in a punk rock band. But I also really liked rocks. In fact, I still have friends that make fun of me for the time that they came over and I was washing my rocks in the driveway. So, be yourself. You don't have to be somebody that you're not. And just, go for it. Yeah.
Yeah, forget stereotypes. I know there's a lot of, like when we talk about women in STEM and, sometimes like, online, you'll get tweets that are like, oh, you look too girly, or you look too this. It's like, it doesn't matter. Anyone can do anything they want. Just, if you're passionate about it, just be yourself and be what you want. And like, you know, I mean, I was, a tap dancer, which is not that cool, apparently. I've learned later, since I've told people that. You know, but also I was, you know, prom queen, so it's okay. So people thought I was cool, apparently. Okay, and I don't know if anyone else has a question, or I can start reading some of them. Oh, okay, good.
Do you know the percentage of women that do work at NASA currently?
Can you repeat that?
Do you know the percentage of women that do work at NASA currently?
So at NASA, overall, we're about 30% female within the technical fields. But I will say, I have never felt like that's been an issue for me personally. When I first started in engineering, my teams within engineering have always been pretty darn close to 50% female. And so everyone's really welcoming, and it's been a great place to work from that perspective.
Yeah, I don't know if any percentage. I think, you know, some of the fields are becoming more equal, but we would always need.
Yeah, I mean, my experience is a little bit different. When I interact with NASA, usually I go to NASA, the leaders of the projects, because one of my research projects is co-funded by NASA. And so when I go to those scientific meetings, then I see a lot of older white men. So being a woman there is still a minority, but it doesn't really, it doesn't make it harder on me, but it's something that I notice, and it's something that I know NASA is really changing right now. So there are instances when you will see less representation, but that's fine. We can do this, totally. You can do it.
Colleagues that are minority and women, and if you do, like roughly how many do you?
So I work at City University in New York. We are a minority serving institution, and our faculty really do represent our students. So I have, I would think that I have more minority and female colleagues than people in other institutions in New York City. And I feel that they work hard, and they attend lots of outreach events, because oftentimes they are invited to talk about their experiences, but they are just brilliant and doing excellent job. So you may hear some, you know, different stories or different experiences, but there are lots of places out there with minorities well represented in the institution, so you can have supports for students and also for the people who work there.
Yeah, and I would just add that our society is recognizing that women and minorities are still underrepresented in many STEM fields. So there are a ton of opportunities at the university. When you get into the university, it's one of the first questions you should ask around to figure out what opportunities are there for you to receive grant funding. So there's a number of programs that are sometimes bridge programs into graduate programs as well. So there's a lot out there right now that will help increase the diversity in these fields, which is absolutely critical.
No, you're right. I mean, it's when I did geology as my undergraduate degree, and every single one of my professors was a white man. So, you know, there's a lot of work to be done in certain fields, and geosciences is one of them. So I say just, you know, there's great bridge programs, and, you know, once you get to university, there'll be tons of resources.
Thank you.
Welcome. We have time. Time for a couple more questions.
Hi, I'm actually not a student. I'm representing Senator Tim Kaine, and I wanted to just ask the panel, were there programs or federal funding that helped you when you were in high school or in middle school that we could advocate for and continue to fund to make sure that these opportunities remain for our students?
I think there's a lot more now than when I was in high school. And I think the director spoke to some of those, some of the science camps and getting involved in you guys can already be interns at NASA, right? So I think there's a lot more now than there was when I was in high school.
Yeah, I don't think I did any federally funded internships, but now there are. I mean, I know with NASA having the age of 16, like that's amazing. But National Science Foundation and NASA are doing great work getting young people, maybe not directly in an internship, but just through other enrichment. So advocate for that's good that you care about that right now.
I was going to say that NASA has, we work a lot with the space grant communities within the different states, and so there are a lot of very state-specific programs that are out there for high school students that you can get involved early. Those range from summer camps to helping you get into some of the NASA internship programs. So those are readily available from the NASA website. You can actually find a lot of those opportunities directly.
Thank you for that question.
Hi. So I'm interested in going into an anthropological and archaeological field, and I've had a lot of people tell me that I'm not going to make it because of the growing economy and like the money that I would supposedly make in that field. And so I was wondering, how have you survived so far with money, and how much your income is in today's growing economy?
That's an interesting question.
We're doing fine. You're going to be fine.
Yeah.
Yes, you're going to do fine.
Yeah.
That's it. I mean, you can be you can be a researcher, a university professor. There's so many jobs out there. But above all, if it's what you love, just do it. It's going to happen. Good things happen to people who are doing good and fighting for what they believe. I can tell you guys that what I make as a university professor is about half of what my husband does in the private sector. But I could be a single mom with my salary. I could find a place to live. I could raise my kids in public school and have a very decent life. So don't let that talk, steer you away from what you like.
Right. I think that's a really important question to ask, because I'm glad that you're thinking about it now, because I certainly didn't. And I mean, it ends up working out well, but you do spend a lot of time in training. So as you point out, like, you're maybe training a little bit longer than some of your friends who might be like business majors, and they can get a job, maybe get paid more faster, but you'll be fine.
Hello? Thank you. I have some questions more specific to biodiversity research. Would you say that there are certain indicator species that are likely to be seen across multiple types of environments that would indicate the health of the environment?
That they would indicate?
The health of the environment?
Yes. So we do have indicator species, and scientists tend to monitor those closely. Usually indicator species are not everywhere. They're not across multiple environments. They're actually very tied to a particular environment. That's why they're indicators, because they would tell you something about the health of that environment. So we do a lot of monitoring of, keystone species or indicator species like that. And it's interesting because it's not saying that they're more important than the other species, right? It's just that they are a reflection of what the other species may be experiencing.
Also, do you find it inaccessible to research some environments or disruptive to research them? If
I find it hard to research some environments, no. Well, not the terrestrial environments that I've been working on. Maybe these guys will have a different story for you. But I feel like in biodiversity science, it's a pretty open field in terms of, and it's pretty accommodating in the sense that people will acknowledge and thank your contribution wherever system you may be interested. I'm interested in, I want to do lions in savannas. I wanted to do frogs in tropical forests. I have friends who do tundra, Alaska, right? Marine systems. I think that there's funding to go around from these wonderful institutions that are here today with us to do all the science across the environments that you want. So you can really, set yourself up based on what your heart tells you or the experiences that show up for you.
Do you find it disruptive to some environments to research them?
Yeah. Okay, now that's the second part of your question. Some may, right? I mean, if you have environments that have been very heavily disturbed, you want to be careful about what kind of studies you can do. But the reality is that we are being able to study biodiversity in less and less invasive ways. Remote sensing is one of them right now. So right now we can monitor migrations from space. We can monitor the trees from space, and therefore we can make inferences about what's happening on the ground, right? So that alone, you're not even touching, you're remotely sensing this diversity, right? And when you do sampling, my sampling is kind of invasive. I mean, lots of times I have to take some biological material of the species I study because I'm sequencing DNA from them. But right now, you could just do a swab of the skin of some of these frogs, and you're going to have enough DNA on their skin cells that you can, get information from. So I think technology is taking us to that, step.
Thanks.
Thank you.
I hate to cut this off, but I have to, because you have an amazing thing coming up that will be live from Antarctica, so I have to get to that. But I just want to give a round of applause to these wonderful panelists. Thank you so much. Your questions were amazing, and they're amazing. So you're so lucky to have them here today. Yeah, and some of them will be sticking around, so maybe you can catch up with them after. But right now, I have to toss it to Antarctica. NSF's Dina Headley will be moderating a Facebook Live, so live from Antarctica, and you'll be able to talk to them. So that's going to come up right now. So thanks so much, everybody.
I'd like to take a minute to thank the administrators, the staff, the television production crew here, the teachers, and especially the students for having us here today and helping us have this day here with you. In just a few minutes, we are going to be connecting with the National Science Foundation's McMurdo Station, Antarctica, where two very special guests are standing by. You'll be able to follow that video feed right here on this screen. We will also be streaming this live to the NSF Facebook page, where our guests will answer questions given in advance by the T.C. Williams students. They will also answer questions live from our Facebook followers. So give me a minute to connect with the bottom of the world, and we'll get started. Hello, McMurdo. Can you hear me?
Yes, we can hear you. Can you see us?
Yes, we can see you here.
Hey, well, welcome everyone to the middle of our Antarctic summer at McMurdo Station. It's very windy, and if we move around a lot, it's because it's quite cold and snowy today. In fact, it just got a lot windier. So McMurdo Station is the biggest of the 3 U.S. research stations in Antarctica. We have about 900 people right here now, and it allows us it's really our platform to get elsewhere in the continent, such as South Pole Station. Antarctica, as you can see from the fact this is the middle of summer, is a very unique place, and it allows us to do very unique research. One area of research is really studying Antarctica itself, the animals that live here, the ice sheets, and how the ice sheets affect sea level. We also look at how Antarctica and its oceans and its atmosphere affect the rest of the globe. So Antarctica has a big influence on other things in the rest of the planet. And the third types of research we do here are using the fact that Antarctica is very unique to do unique types of research at South Pole Station, where because you're on a very thick ice sheet, it's dark all during the winter, 24 hours a day, and the air is extremely clear and extremely dry and extremely cold. Things such as the South Pole Telescope are able to look out into the universe and look at things such as how the universe is formed. And also the thick ice sheets at South Pole Station. We've instrumented it with sensors, and it's now a very large neutrino detector and neutrino observatory. So the research we do here is many, many different types, but it's all very unique. This year, we're celebrating the 50th anniversary of the first all-woman research team that in 1969 went to South Pole. It's really exciting for us because right now, if you walk around the lab here at McMurdo Station, about half the researchers are women. And that's a lot of progress to make in 50 years, which is a relatively short time, especially for me since I'm old. And today, one of our researchers, Dr. Ann Todgham, is here with me, and she's going to tell you a bit about her research.
Yeah, well, welcome everyone to the Antarctic. It is really one of the coolest places on the planet to be able to do research. I'm lucky enough to be down here. I'm a faculty member at the University of California, Davis, and I get to work out on that great sea ice that you see out there. This is my 5th season coming down here. I started back in 2006 studying how cool and well adapted the fishes are down here to being able to live under these really unique and specialized conditions. I'm now down here with a team of my own. So I have a bunch of graduate students that are with me, and we're looking at how these animals that have evolved under really stable conditions, how are they coping with change? And how are they going to be able to cope with things like ocean warming and ocean acidification? So, you know, it is, like Dr. Isern said, it's summer. It's about, I don't know, maybe it's about 10 degrees Fahrenheit right now with the wind chill. I've been here for almost 4 months. When I got here, it was minus 45, so this jacket came in handy. We had about 8 hours of daylight. Now, I haven't seen the sunset since about 6 weeks ago, so we have 24 hours of sunlight now. And I would just say it's amazing to be able to work out here. It looks pretty barren to you, but should you go underneath that sea ice, you'll just see this amazing bounty and biodiversity of life. So I think we're ready to maybe take some questions.
Yeah, I'd love to take questions.
We are so happy to have you with us today. Thank you so much to both of you. Our first question from T.C. Williams, the audience here, is why is Antarctica, or specifically McMurdo, the ideal place to conduct research?
Well, so the nice thing about McMurdo Station is it really is the hub of the U.S. Antarctic program, and so it has great facilities for us to be able to do the work that we need to do. So for me, what that involves is being able to collect animals from out in the Sound, bring them back into our aquarium facility, which is really great and allows me to hold these animals under these sort of future ocean scenarios for months at a time. That's something that I wouldn't be able to do a lot of other places. And then, you know, for others, we have great penguin colonies nearby. We have a lot of seals that are pupping right now. So the access to the animals that we need, if you're a biologist, or the access to the different types of environments is perfect for right here.
The other thing is McMurdo Station is actually situated at pretty much the farthest south that you can get on the Antarctic continent and still reliably approach with a boat, for example, which is why many of the explorers that when they first tried to reach South Pole left out of here because it's so far south.
So that leads us into our next question from T.C. Williams here in Alexandria, Virginia. How much of Antarctica has been explored?
Wow, it's interesting. Not a lot at all, actually. If you look at a map of Antarctica and where the stations are, this is by far the biggest station. Many other countries have research stations, but they're quite small, and some don't have people here year-round. So all 3 of our U.S. stations do have researchers year-round, but Antarctica is a huge place, and if you see the extent of where the stations are, it covers quite a small area. I would say we've done a lot of airborne surveying, for example, of flying airplanes and using radars, for example, to map under the ice and do research like that. But actually going out into the field, like Dr. Todgham does, it's actually a pretty small area. It's a big challenge, actually, to understand, for example, things like the weather predicting the weather here is very hard because we have very few weather stations on the continent to be able to run weather models and do forecasting.
Yeah, and I would just add one of the, I guess one of the things that is so exciting as a scientist down here is there is so much that we don't know because we're just at the tip of an iceberg of figuring out what's going on in the various places that we study. And so, I think that's one of the things that I think that brings us back year after year.
That's great. Another question from T.C. Williams is, how does your work affect the world?
Well, so as someone who studies stress in animals, I like to travel all around the world and look at the same kinds of questions in lots of different species. And that allows me to understand some of the unifying themes that might make species vulnerable to things like warming or things like low oxygen. And so by coming here, I can look at the most specialized animals there are on the planet and use that to help me predict how species that live in other parts of the world might be able to tolerate change.
And we have a very big project going on right now that we're collaborating with the British Antarctic Survey, where we have multiple teams of researchers going out into West Antarctica to look at the West Antarctic ice sheet, which is an ice sheet that's very thick, but its base is actually below sea level. So there's strong evidence that that ice sheet could collapse in the next 100 years. And so if that ice sheet, as it's slowly starting to lose ice, it's causing measurable sea level rise. So that's another area where, as Antarctica and the ice sheets warm, we're seeing that the continent has a great effect on global sea level and sea level rise.
So Anne, someone here at T.C. Williams would like to know, what made you want to go to Antarctica? And what is it like to live and work there?
Oh my goodness. So I think it started, okay, two things. I always have loved to travel. I've been really lucky enough to be able to travel quite a bit in my life, but never had the opportunity to come to the Antarctic. So there was always that I should get my seventh continent. But when I went to school, I learned about all the really cool things that animals can do down here. So as a physiologist, I'm interested in how animals work, and how animals work down here is different than anywhere else. And so that sort of really drew me here. And so as a scientist, what I do is I write a grant to the National Science Foundation, who funds the work that we do down here. It then goes out to a number of colleagues in the field, and they look at, does the science make sense? Is it going to tell us something important? And that allows us to come down here and do the work that we're doing.
And our first question from our Facebook followers is, how much plant life is there around McMurdo or on Antarctica as a whole?
There is no plant life in McMurdo at all. Nothing that you would think of as a plant. In the Antarctic Peninsula, south of South America, you do see mosses, some fungi. I found a mushroom once, which probably shouldn't have been living there. But very, very, very little, very little. Because you have essentially 24-hour darkness for much of the year, for at least a good 4 months of the year, makes it hard for things to grow. But
yeah, Dr. Isern's not mentioning the only plant life we have down here is in the galley, which is our freshies.
Yeah.
So the previous question was asking a little bit about what life is like. What we love is when big planes come in full of things like fresh fruit and salad, so that we get some plant life. But really, actually, to be honest with you, the food down here is outstanding.
We're actually not allowed to bring plants down here either. We're very careful about not transporting any organism that may become an invasive species here. And for example, the mushroom I found was probably a spore that maybe got carried by a bird. And as the Antarctic Peninsula is warming, it's making it more hospitable for organisms that shouldn't live there. And that's happening in the marine environment too. We're starting to see organisms come in that shouldn't be there, and it's affecting the ecosystems.
Here's another question from Facebook for either of you. Are there any challenges you faced with being a woman in STEM?
You know what? I would say I've been really lucky. I've had a lot of women who have sort of kind of bridge this path for me ahead of me. I have, for me, it's been a great experience. I haven't had many challenges being a woman. I've had a challenge of being, a junior scientist coming up through the ranks, but I think that would be the same for my male colleagues as well. But I think I owe that a lot to the women that came before me who really broke the ground and really set the stage for all of us who are here now working in Antarctica.
Yeah, and I would say I'm older than Dr. Todgham, but no, I would say that it's gotten a lot easier, and I think part of it is that as I said, half the researchers here are women, and I think the women are very good mentors to each other, and they, they're there to help, all the young researchers develop professionally, and I would agree. I think, the males and women and any diverse students, everybody faces challenges, but it's overcoming those challenges with the team and with good mentors that makes science so exciting.
Yeah, and I would just add one thing is for me as someone who's coming up and sort of seeing what's ahead of me at NSF, the leadership at NSF is largely women when it comes to the Antarctic program. And so to have these role models in those types of roles for us is really great.
One really great question just came in from T.C. Williams. What advice would you give to students who want to go into a similar field?
Yeah, you go.
I guess my advice is just be curious. And if something gets you excited, go for it, do it. I mean, I was the kid that was always in the intertidal zone turning over rocks. I was down in forests looking for slimy things. And even though my friends were like, ew, that's gross, I just kept doing it. And, I think do what you really, really want to do. And if you're feeling like you're not good at something, listen to your cheerleaders, because a lot of us have cheerleaders in our lives when we're not feeling like we're really good at what we do that keep telling us, you're great at this, just keep at it. And so remember, there are going to be people that are going to cheer you on and listen to them.
And I would say, too, do a lot of different things. Don't feel like at your age, or even if you're a bit older, you don't have to decide right away. I mean, always kind of build a network of things you're interested in, and don't be shy about writing. There's a certain area of research you like. Don't feel shy about writing someone and asking them questions and just really exploring different things until that one area of science just hooks you and you just feel that passion.
Another question from T.C. Williams here. How do the fish survive in such cold water? Do they have special gills or fins or scales that help them keep them warm?
Well, that's a great question. So, so if I were to take a trout, which would be a fish that I would study in California, and put it out here, it would freeze. So the fish down here have a lot of adaptations, one of which is antifreeze proteins. So these are proteins they carry around in them that prevent them from actually freezing solid at these sub-zero conditions. But the question about the gills in the skin, that's a very interesting question. So I study baby fish because baby fish are predicted to be more vulnerable to change than adults. And when they're really young, many of them don't have antifreeze proteins. So they rely on their scales and really, really sort of not fully developed gills to keep the ice out.
Well, that's great. Another question from T.C. Williams. How can students like us help to preserve biodiversity in our community?
Okay, so that's a very good question. Now, what we need to be thinking about is to preserve biodiversity. There are little things that we can be doing at home. We can be talking about what you're learning at school, at home. In terms of preserving biodiversity, I think paying attention to what's there, not doing anything overly, how do I say this? Keeping natural spaces natural and being able to go to the national parks and looking at all the things that are there, that would be some things that you could think about.
Great. The next question is from our Facebook followers. How we convert Antarctica to a new habitat as tourists, perspective like a fun place. That didn't make sense.
Could you repeat the question
again?
Yeah.
I'm not sure it came in right. Hang on a second here. hang on a second. They're checking it out. Here, just a minute. It was a Facebook question. Just a minute.
No worries. My earpiece keeps getting blown out of my ear.
Yeah, it's quite windy.
I do see that it is snowing there. How long has it been snowing?
Not long, probably since this morning, but we've actually gotten almost record levels of snowfall for this past week. Very unusually high amount of snowfall for this time of year. In fact, if it weren't snowing, there's beautiful mountains behind us here, which you just can't see because of it's quite foggy as well.
Yeah,
Okay.
so we had actually on, oh, we're back.
No, go ahead. Go ahead. Please go ahead.
Oh, no, I was just going to add that, so Sunday is everybody's day off here, and on Sunday, there was a town snowball fight.
Yep.
Because we never get snow, and there was, snow up well past our ankles, and it was really, really fun for everyone out in this one huge parking lot that we have in front of our dorms. We had a big snowball fight.
Yep.
Oh, that's a lot of fun. Okay, we have another question from Facebook. Do any tourists visit McMurdo Station?
They do. It's not as common as in the Antarctic Peninsula. The Antarctic Peninsula, south of South America, is the primary tourist area, in part because the normal cruise ships can get into that area, and it's also, there's narrow fjords, and it's just absolutely spectacular scenery. In McMurdo, because we have a lot of sea ice during a good part of the summer, the cruise ships can't get very close here, so a few of the bigger icebreaker type of cruise ships will come in here, but it's relatively rare. I would say it's rare enough that it's a quite special event. We're in the peninsula. If you're at Palmer Station, which is our research station in the Antarctic Peninsula, it's quite common that the cruise ships come in, and we will actually go out to the cruise ships and give talks about the research program and things like that. But tourism is on the rise. There's a lot more tourism now than there was, say, 10 years ago.
Yeah.
Another question from Facebook. What is the strangest thing you've seen during your time in Antarctica?
Wow, it's a good one.
Oh,
I'll let you go first.
The strangest thing I've seen. Okay, well, so one of the strange, cool things I've seen is we found a fish species down here that wasn't supposed to be here, and it's a dragonfish with these, you can't see, but it's basically, let's say, the thickness of your thumb, and it has these massive teeth, so it looks like this critter just from outer space, or maybe the deep ocean. So that was one of the strangest kind of animals that I've seen down here.
I would say the strangest thing, or the most beautiful thing I've seen, is at Palmer Station, because Palmer Station is actually north of the Antarctic Circle, even in the summer, you still get a little bit of dark, very, very, like maybe an hour or 2 hours, and the light changes near the dark, near night, it changes to purple, so that all the ice around the station turns this beautiful lavender, pinky purple color, and it's just spectacular, absolutely spectacular.
Okay, one other spectacular thing, because you said spectacular things, is the mirages. The mirages down here that we get just out here on the really, really clear days are phenomenal. It's actually, you're on the sea ice, everything is white, and then there's these sort of strange, almost looks like skyscrapers all along the horizon. It's pretty cool.
Yeah. We have another question from our Facebook followers. From Put-in Bay, Ohio, 7th grade students would like to know, have you ever been stuck down there and unable to get home because of weather?
Right now.
Right now.
Right now. We normally have a plane going north or south every other day, and we've had 2 in the past 2 weeks. So, yes, actually we have about 200 people here that want to go home, 290 people that want to go home for Christmas. And as you can see from the weather, it is not likely we are going to get a plane today.
No.
So we also had 200 people sitting in Christchurch, New Zealand, waiting to come and start their research. So it's very seasonal, but occasionally they'll get us out, but maybe not on the day that you want to leave.
Yeah, I mean, I think one of the things that's great about being down here is that you have to be flexible. And when it comes actually, so that comes with the science, that comes with the sea ice season where we've had thinner sea ice than normal, but it also comes with travel. Yeah. We spent 2 weeks in Christchurch before coming here, and hopefully it's less than 2 weeks of extra time here before we leave.
She's been here 4 months. She wants to go home for Christmas.
Wow. So for the students here, what kinds of classes would you suggest they take if they want to come down there and do science in Antarctica?
I mean, for me, I think in terms of the sciences, I think a lot of the math classes are important. I think some of my most influential high school teachers were my math teachers, as well as my science teachers. So, you know, I think as much as maybe you're not a math person or maybe you're not a chemistry person, I think at least for what I do, it's very important. And so you rely on your teachers in high school, and when you get to university, don't be scared of professors. Go and ask them when you have questions if there are things you don't understand. But that would be, I would do that, and then I would just second what Dr. Isern said about, you know, sometimes you don't know when a class will be really important for what you want to do next. So don't pigeonhole yourself into something that's really narrow right off the bat. Be open.
Yeah, and I would agree. You know, it's taking a wide range of science because it always helps you. Yeah. I'm a geologist by training, but I would say that, you know, some of the biology classes I took, I use just as much as the geology classes, the physics classes that I took. All the things, you know, you can never go into class and say, oh, I'll never need this again, because you just don't know. And it just helps you broaden the science that you do. And I would say right now, if you could walk through the lab with us, there's no scientist in there that is doing science that's very pigeonholed and very narrow. Everyone's doing very interdisciplinary research, and the broader the understanding you have of science allows you to talk with your colleagues and really push the boundaries of knowledge and of things we don't understand.
A question from our Facebook followers. Have dinosaur fossils been discovered in Antarctica?
Oh, yeah, definitely. And actually, it's dinosaurs. We found petrified forests. Cryolithosaurus, in fact, is our very own Antarctic dinosaur. And it's a really interesting question, because Antarctica as a continent, even though the continents on the rest of the globe have moved around, Antarctica has pretty much stayed right where it is in the southern part of the planet, which means that even during times when there was no ice on the continent at all, it still would have had this day-night cycle where in the summer it's daylight all the time, and in the winter it's dark all the time. So the question is, how would you get big forests when half the year there was no sunlight? And they were photosynthesizing plants. And the same with dinosaurs. You know, they're presumably were cold-blooded, and how were they surviving in an environment where half the year, or about half the year, it was dark? So we definitely do, and that's a big area of research for us. In fact, right now at the LA Museum, there's a big exhibit on Antarctic dinosaurs that will be traveling around the country.
Well, I'd like to welcome the 7th graders watching from Crandon, Wisconsin. They would like to know, how many species of animals live in Antarctica?
Oh, wow. That is a great question that I don't know the answer to. I can tell you there's about 300 species of fish. But other than that, I think
we don't know.
Yeah.
I mean, in part, you know, it's again getting back to an earlier question about, are there still things to study? And I think the biodiversity in Antarctica is still an area of research. For example, one new thing that we've learned in the past 10 years or so is that underneath these many miles thick ice sheets, there are lakes. Mm-hmm. And in those lakes, there's whole microbial communities that we don't really fully understand yet. So I think we don't, in some cases, don't really know.
What we do know is that, you know, what we have seen is that the biodiversity here is lower than in other places of the planet. And I guess why a lot of us are here is that the animals that you can find here, you can't find anywhere else on the planet. And so it's not, when we think about animals that move poleward because they're trying to track cooler waters, it sort of begs the question, where do Antarctic species go? They're already as cold as it can be. And so, the animals we do have here are rarely found elsewhere in the world.
So a question from our Facebook followers. How can we get one of those great coats and hats you both are wearing?
Well, you can go to Canada Goose, actually. They're Canada Goose coats, and it's actually funny for someone my size, which I guess you can't really tell, but I'm about 5'3", and this coat comes about to my knees. So when I'm walking around the base, I generally don't wear it because it's so big. But because you feel like a penguin, if I fall over now, I probably have to have someone help me up. But I can tell you right now, I very much appreciate this coat. As we've been talking, it's getting colder and colder. Yep. But yeah, they're pretty great coats, and they're a really important survival part of our equipment that we have, because if you ever needed to, this thing will keep you warm for sure.
Yeah, so every day I go out on the sea ice, I bring this with me, even if it's a beautiful day, because you never know when weather will turn like this in an instant. And it's like you're wrapped in a duvet. Yeah, I love it.
We're actually, anytime we leave an established road in McMurdo, we have to have not only this coat, wind pants, Arctic snow boots, and a full set of gear, because again, if a vehicle breaks down and you're stuck in freezing weather, you really have to make sure you're safe. So we actually, this is one of the most important pieces of our safety gear.
So if you're out in the field and you get stuck out there, something breaks down and you can't go any further or can't get back, do you just grab your cell phone and call McMurdo?
No, we have no cell service at all. And in fact, our internet is not that great either. So we do carry radios with us. So anytime you leave an established road, you have to check in with our MAC Ops, so our operations system here. You check out. You may have hourly checks or periodic checks, and then you have to check back in, and if you forget, they will send out a search and rescue team for you, and there's nothing worse than having them do that and you're eating in the galley. But we always carry a survival bag with us as well. So in that survival bag is enough food and extra clothing and tent and equipment that you would need to have 2 people survive for 3 days. So again, we're very, very careful to have a lot of redundancies too, to make sure that for example, if I go out, I'm always going to carry extra long underwear, extra shirts, extra socks, so again that you can just be safe.
Yeah, and we all have, especially with us on the sea ice, we're traveling in vehicles that act as a shelter, so we can hang out in that. The nice thing about the bad weather is at least around here, it'll pass. So you just hunker down. Maybe you were lucky enough to remember to bring a deck of cards. And
in fact, the survival bags all have a book in them because it's 24-hour daylight, and 3 days will go very, very slow if you're stuck in a tent. So they all have actually a terrible romance novel in them.
That's great. We have about 5 minutes left, and I think we have time for one more question from Facebook. How many scientists stay at the station over the winter, and what research would they do during that time?
It's actually, so here at McMurdo Station, we generally don't have a lot of scientists staying. We have generally groups looking at upper atmosphere research. So for example, one group, they're using lasers to look at the upper stratosphere and how the temperature changes during the winter and also in the summer. At South Pole Station, that's actually the peak of their research season. So they have about 45 people stay at South Pole Station for their winter season, which is actually 8 months long there. It's quite long at South Pole. And of those 45 people, I think about 15 or 20 are researchers. Palmer Station, they may have about 5 or 6 on average researchers there, although this year they had quite a big research season. There was a researcher looking at Antarctic krill, and she and her research team were there all winter and doing research. So
So that's about all the time we have for today. I'd like to thank our guests, Dr. Alex Isern and Dr. Ann Todgham, for joining us today from Antarctica. I'd also
thank
like
you, and thanks for, yeah, thank you.
Yeah, thank you.
I'd also like to thank our guests and all the students here at T.C. Williams High School, as well as our Facebook followers for participating in today's Facebook event. This concludes our Facebook event. Thank you and goodbye. Bye, everybody.
Bye, everyone.
Bye.
Send good weather.
Send a plane.
Send planes.
So now I'd like to wrap up the event. I'd like to introduce Amanda Greenwell. She is the head of the Office of Legislative and Public Affairs at the National Science Foundation. Amanda Greenwell.
Thank you, Dina. Wow, what a session. I just have to say, hearing the STEM Sparks earlier reminded me of one of my STEM Sparks, which was actually my sophomore biology class in high school, where we were dissecting squids. And to the person who answered or asked the first question about kind of what were you like in high school, those kind of things, I helped the varsity football team, helped them actually dissect that squid and made a lot of friends that way, so just be you. On behalf of the National Science Foundation, I'd like to express my appreciation to all the students here today and to Alexandria City Public Schools and T.C. Williams staff for their support and dedication in the coordination of this event. This event will be one of many more to come, and my staff and I look forward to working with you in the future. Thank you to all the speakers, the panelists, and NASA for participating and sharing your amazing career experiences with our future scientists. To all the students, as you can see, our participants are examples of what's possible. When you leave here, when you imagine your future, when you dream of what problems you want to solve, think of these amazing role models. They show you can succeed in STEM fields. That matters because each of you will shape the future of the United States. What our nation needs is more STEM professionals because STEM professionals work on the cutting edge every day and they are solving real-world problems. So don't be afraid to dream. Follow your imagination. That's what STEM is. It's the pursuit of dreams and ideas. And pursuing a path in STEM will lead you to amazing places. And as I mentioned before, I know this personally because a fascination with the ocean took me from landlocked Nebraska, go Big Red, to Hawaii, where I studied marine biology. And the path to studying marine biology led to an internship in Congress and ultimately here, where it's an honor to speak with you. And I have no doubt in this room today, we have the future of major discoveries. So thank you.